Today we're talking about absolute value equations and inequalities. So we're solving for the absolute value of x plus 5 is equal to 11. So we want x by itself. So the first thing we're going to do is subtract 5 from both sides. The absolute value of x is equal to 6. Now we know that anything inside the absolute value is always equal to a positive. It means that x could equal 6 or x could equal negative 6. So let's check our answer. Let's check our answer to see why 6 or negative 6 can be the answer. So if we check with the 6, so the value of 6 plus 5 should equal 11. 6 plus 5 is equal to 11. And that is true. If we check with negative 6, the absolute value of negative 6 plus 5 should equal 11. The absolute value of negative 6 also equals a positive 6. 11 equals 11. Yes, sir. Yes.
So it's always going to be both negative and positive.
When we have the variable by itself inside the absolute value, yes.
So
We have to solve the absolute value of 2p plus 5 is equal to 11. So we have to write two equations. We're going to copy this equation exactly the same way. 2p plus 5 is equal to 11. And the next one is going to be 2p plus 5 is equal to negative 11. So in one of them we have a positive 11, in the other one a negative 11. And we're going to solve each of these. Minus 5, 2p is equal to 6. Divide by 2, p is equal to 3. And this other one, going to subtract 5 from both sides. At 2p equals negative 16. And we're going to divide by 2 on both sides. P is equal to negative 8. This means p can equal to 3 or p can equal to negative 8. If we check this, that the absolute value of 2p plus 5 should equal 11. So this is the absolute value now. Let's check. This means the absolute value of 2 times 3 plus 5 should equal 11. 6 plus 5 should equal 11. 11 equals 11. This is correct. 2 times negative 8 plus 5 should equal 11. Negative 16 plus 5 should equal 11. This is true. They're both true. Let's look at this equation. Negative 5.5 is equal to the absolute value of t plus 2. Will the absolute value of something ever equal a negative? No. Therefore, there is no solution. Now, if you work this out and you get negative 5.5 is equal to t plus 2, and you go ahead and subtract 2, you get negative 7.5 is equal to t. If you check it, you say negative 5.5 is equal to the absolute value of negative 7.5 plus 2. You get negative 5.5 is equal to the absolute value of negative 5.5. But the absolute value of negative 5.5 is positive 5.5. So is this true? No. Therefore, there is no solution. And I didn't work it out with this as a positive. But because of this, there is no solution. If we have the absolute value of x minus 3 is greater than or equal to 4, and we have to graph the solution. have to solve this first of all, so we're going to say x minus 3 is greater than or equal to 4. And because this is a greater than or equal, and this is positive, we know it's going to be an or. X minus 3 is greater than or equal to negative 4. So notice, the same way as we worked out the equation, we do one exactly the same and the next one with a negative 4. Now, what did Miss Albsoute do wrong? Well, when we're working with a negative 4, we have to flip the sign. Just like we did when we were multiplying and dividing by a negative. So what's the other thing that changed? The sign. So to start off, we keep one exactly the same and the other one, we flip the sign and we change it to the opposite. Are we okay so far? We can work out each of these. So plus 3, x is greater than or equal to 7, or x is less than or equal to negative 1. When we graph these, start with our number line, negative 1 and 7, x is less than or equal to negative 1, and x is greater than or equal to 7. If we have to solve, the absolute value of w plus 2 is greater than 5. Will this be an or an and? Or, so we can say w plus 2 is greater than 5, or w plus 2 is less than negative 5. And we solve each of these. And we graph them. So w is greater than 3 and w is less than negative 7. Question. We have to find the absolute value of p minus 4 is less than or equal to 3. If p minus 4 less than or equal to 3, and because this is a less than, and p minus 4 is greater than or equal to negative 3. So when we solve, we add 4, p is less than or equal to 7, and 4, p is greater than or equal to 1. So we can graph these. Can we rewrite this as a compound inequality? So 1 less than or equal to p, and p is less than or equal to 7.